Which brings us to tonight's speaker, Kevin Hennessy. And Kevin's going to be talking about climate change. Thanks for giving up your evening, Kevin, and your time. I know you've travelled a long way to get here, and it is cold, and then you'd rather be doing other things, I'm sure. Kevin's the theme leader in the Climate Adaptation flagship at CSIRO Marine and AtmosphericResearch. He's a principal research scientist at CSIRO Marine and AtmosphericResearch, and he's been involved in climate change research for over 26 years and currently leads the Pathways to Adaptation theme, in the Climate Adaptation flagship. Amongst over 200 publications, he has analysed the impact of climate change on drought, fire, snow, extreme temperature and extreme rainfall, and he's contributed to IPCC assessments on climate change since 1996. This has included being a coordinating lead author of the Australian and New Zealand chapter of the 2007 IPCC report on climate change impacts, adaptation and vulnerability. More recently, he was an expert reviewer of the chapters on Australasia and small islands in the 2014 IPCC report. 2012 and 2014, he was a co-author of the State of the Climate report published by the CSIRO and the Bureau of Meteorology, and he's been a co-author of many reports on regional climate projections for Australia and the Pacific. And he is part of a team producing new projections for Australia. I'm going to embarrass you, Kevin. If I can only get away with it because you are my cousin. But Kevin, the team that Kevin leads here won a shared
we all have problems with
Nobel Peace Prize. What year was that, Kevin?
2007.
2007, that was the Nobel Peace Prize, and shared of all people, Al Gore. So without any further ado, Kev, thanks for giving up your evening, mate, and thanks for coming along.
Thank you, Carl. Cheers, mate. Thanks, Carl, and thanks everyone for having me here tonight. I hope this is a reasonably interesting talk for you. It'll go for about 45 minutes plus questions, and I'd encourage you to ask questions as we go through rather than holding your breath until the end. So once we incorporate the questions, I suspect it'll go for a bit longer than an hour, but that's all fine with me. So the first point I wanted to make was just around how difficult it is to communicate some of this information about climate science. There is so much information out there. You can get information from individuals like Al Gore, who I've got up there, from movies like The Inconvenient Truth, from journal papers and such as journal Climatic Change or others like Science and Nature. You can get information from books that are published, say, by the CSIRO or by what used to be the Climate Commission. There's one up there. And guys like Tim Flannery, who were leading the Climate Commission, which has now been closed down, and it's now the Climate Council. And of course, there's lots of stuff in the media as well. So it's really hard to know who and what to believe. You know, what are the trusted sources of information about climate change? So I'll try to guide you through this labyrinth of information. And some of the links up there are to surveys that have been done about the fact that most people accept that there is some climate change going on, but they want to know more. They really want to get into the evidence for climate change. So let's try and step through that. I really wanted to emphasise how we sort the wheat from the chaff. Where is the trusted information about climate change? And it really comes from what we call the peer review process. And this is a process by which we assess the credibility of information that actually is published. And so without this process, a number of different agendas might play into what you read. And just sort of in brief, the peer review process for articles that are submitted to scientific journals essentially requires us to write a manuscript, submit it to a relevant journal. It's then reviewed by 2 or 3 independent experts, and they pass their comments back to the editor of that journal. And then it's the editor's job to determine whether that particular article should be published or should be rejected. And so what actually passes through that process of scrutiny is actually high quality information. And that's the stuff that I'll be referring to tonight. Carl mentioned the IPCC, that stands for the Intergovernmental Panel on Climate Change. It was established back in 1988 by the World Meteorological Organization. And it does regular assessments of the peer-reviewed literature. They've done about 5 assessments now, the 5th of which was just published in the last year or so. Because it's intergovernmental, it actually involves a lot of the governments from around the world, 195 in total. And as I said, the 5th report was just published. It's published in 3 volumes. The first was published last September, and the most recent 2, which are on impacts and vulnerability and what's called mitigation, which is reducing greenhouse gas emissions, was just published in the last couple of months. So it's really hot off the press. And involved hundreds of authors, and those authors had to respond to hundreds of thousands of comments from expert reviewers and from governments. So it really goes through the ringer. It's one of the most rigorously peer-reviewed reports that I've seen. So let's turn to the evidence for climate change as has been assessed by the IPCC. So what evidence do we have for observed climate change? Well, firstly, there's very clear evidence for a warming of the climate system. Very clear since the mid-1950s, and it's unprecedented in many of its aspects. It's not just the atmosphere that's warmed, it's also the ocean that has warmed. And we've seen reductions in the amount of snow and ice, sea level has risen, and we've seen concentrations of greenhouse gases increasing as well. In terms of the evidence for global warming, various different lines of evidence underpin that. We've seen a warming of almost 1 degree over the last 100 years or so. And that's shown by, whoops, let me go back. I'll get used to this in a minute. Back. Okay, I want the pointer. So this is a record of a temperature anomaly relative to a 30-year period from 1961 to 1990. So these are anomalies or changes relative to that average. And we can see from 1850 through to 2010, lots of wiggles and bumps from year to year. And this is based upon measurements on thermometers across the globe. But it's not until really since about the 1920s that there was a rise in temperature, then it flattened out, and then since the 1970s it's continued upward. And we know reasonably well why there are these ups and downs and why there was a slowing of the warming around this period. This was around about the World War II time, when there was a lot of input of aerosols or dust into the atmosphere, and that actually had a cooling effect that was playing tug of war with the warming effect of the greenhouse gases. But as we've removed those aerosols from our atmosphere just to clean up the air, the warming effect has really started to dominate since the 1970s. And we hear quite a bit about this period here, the last 10 or 15 years, where people say there's been a hiatus, an absence of global warming. And really you've got to be a bit careful about that. And what the IPCC says is that you can't really assess trends over short periods. It's very, very sensitive to the start and end date that you use. So if you looked at the period 1988 to 2012, you wouldn't find much warming. If you looked over a slightly longer period, you would find a warming. So we really need to take a longer term perspective to that. And look, you can see other periods during the record where you might have looked over this period here and have thought not much warming, and then it eventually goes up. And the scientists are quite confident that there will be continued warming from now on.
That period,
Sure.
During the Second World War,
Yes.
it flattened off. Did that apply equally in the northern and southern hemispheres?
It's more of a northern hemisphere effect because the southern hemisphere is dominated by the oceans, and it's a much cleaner hemisphere.
Right.
Lucky for us. Sure.
Are there planes today that kind of chuck out dust or something influencing weather as well?
Yeah, that's a good question. So contrails from aircraft do produce cloud lines. And in fact, what was it? It was during, might have been after the bombing in the US. They actually had a rare occasion where there wasn't much flights taking place in the US, and they could actually measure the effect of before and after, and it's a very, very minor cooling effect relative to other things.
Just on rocket launches would be prominent during that time. Would the space travel kicking off and becoming more and more prevalent have some impact on the global warming?
I don't know if that's been explicitly looked at, but I suspect it would be a relatively minor effect. Yeah. And one of the other points there was just that the last 3 decades, these ones here have been successively warmer than the previous ones, so we've seen very sustained warming in the last 30 to 40 years. But it's not just a warming of the atmosphere, there's evidence for warming in the oceans as well. So we've seen the oceans actually take up about 90% of the change in the energy balance of the planet. So if we're going to look for a signal of global warming, that's where it should be, and indeed it is.
When you say reduction of aerosols after the war,
yes.
as a result of legislation?
Yes, it is. So legislation to reduce the amount of aerosol pollution which affects respiratory disease, and also to reduce acid rain, particularly in Europe. So that's been more effective in some countries than others. In parts of Asia, there's still very high aerosol loading, particularly in China. So the graph at the top here is just showing the heat content of the upper ocean, and that's been steadily rising over the last 50 or 60 years. The graph down the bottom here is showing the global average sea level rise, which is around about 190 millimetres or almost 20 centimetres. In addition to that, we've seen melting of many glaciers, and also when you warm the oceans, they expand, so there's thermal expansion. So it's both the melting of glaciers and the thermal expansion of the oceans that has contributed largely to that sea level rise that we've seen. We've also seen melting of sea ice. Now, sea ice, because it's floating, doesn't contribute to sea level rise, but it does have an effect on how reflective the surface of the planet is. If you make the surface of the planet less reflective, it can absorb more of the heat into the deep ocean. And interestingly, we've seen a reduction in the sea ice extent in the northern hemisphere, in the Arctic, but we've seen an increase in the sea ice extent in the Antarctic. And scientists are not entirely clear as to why that has been happening. I've asked my colleagues who work on this, and they can't give me a really good answer at this stage. So that's an uncertain area.
Wasn't there recently a huge block of ice that broke off in Antarctica? And
That's true. That happens, I shouldn't say all the time, but happens quite commonly. And it's not necessarily linked to global warming. But it is interesting that very large iceberg has broken off. Okay, and we've also seen changes in extreme weather events, and the IPCC has concluded it's very likely that the number of cold days and cold nights has decreased and the number of warm days and warm nights has increased. It's also likely that there's been an increase in the frequency of heat waves, particularly in parts of Europe, Asia and Australia. There's also been more land areas where the heavy rainfall events have occurred more frequently. But there's low confidence in any trends in tropical cyclones. Our cyclone records go back to about the early 1980s when satellite records became available. It's a relatively short record, and the trends are pretty small, some up, some down, so no conclusions yet about trends in tropical cyclones. The other thing that has been happening in our atmosphere is that greenhouse gases have been increasing. We just look at the main greenhouse gases here, so carbon dioxide's increased 40% since the 1750s, which is around about the time of the Industrial Revolution. Methane's gone up 150%, and nitrous oxide has gone up by 20%. It's largely from burning of fossil fuels, but also from agricultural productivity as well. Yep, indeed, production of methane from cows. And the graph here, which is a kind of an interesting one, this goes back some 800,000 years. Starting from the present here and going backwards. And we can see lots of wiggles and bumps. Every 100,000 years or so we have an ice age. So temperatures drop, and as we come out of the ice age we go into what's called an interglacial or a warm period. And we know what causes those interglacial and ice age periods. It's wobbles in the Earth's orbit that either bring us closer or further away from the sun. So that's a natural phenomenon. We understand that very well. What actually happens also during those ice ages and interglacial periods is that there's a natural release or an uptake of greenhouse gases. So the greenhouse gases have reinforced the warming or the cooling during those ice ages or warm periods. Again, a natural effect. Yeah, so as we come down to the pointy end of this period, so humans have been on the planet for 40 or 50,000 years. That has had an effect, but more so, and I'll get to this point, in the last 50 years, and that's where we've seen a big increase in greenhouse gases. But you can see that the greenhouse gases have now got up to about 400 parts per million, as opposed to the natural range, which was around about, say, 180 to about 300 parts per million. So we're outside that historical range that we would have seen due to natural causes. So that's interesting in itself, and we know that it's largely due to human activities and agricultural activities. So let's try and put this all together. We know there's been a warming. We know that there are various contributing factors to warming, both natural and due to human activities. What's the relative proportion? And we can do that using global climate models, which are computer models of the climate system. And they can reproduce past climate, and they can help us understand the future climate as well. So what we can do is use these climate models to understand how they simulate the black line, which is the observed warming over the last 100 years or so. When we run these models just with natural factors, so just, for example, changes in the output from the sun, including the sunspot cycle, which is an 11-year cycle, or changes in volcanic activity, which can put, if you get a really large volcanic eruption, put a lot of dust and other chemicals into the upper atmosphere, where it can stay for 2 or 3 years and gives us great sunsets. It also has a cooling effect. So we incorporate those natural factors, but no greenhouse gases, and we get this blue curve. And it simulates what we've observed in the black line up to about 1950, but it doesn't capture the warming that we've seen in the last 50 years or so. However, when we run these models with both natural factors and the increase in greenhouse gases, and these greenhouse gases act like a blanket around the Earth, enhancing the warming, all of a sudden with this pink curve, we see that it gives us a good match to what's been observed. And so that gives us some confidence in understanding the relative proportion of natural versus human factors in contributing to the global warming.
So is the thickness the uncertainty?
Yes, it is. There's about 20 different climate models that have been used, and they all give slightly different answers. So that's why there's a band of uncertainty.
You were just mentioning that with the volcanic activity, the dust in the atmosphere has got a cooling effect.
Yes.
You also said that the gases have got a warming effect.
Greenhouse gases have a warming effect. Yeah, so aerosols are like the soot and dust that we can actually see in the atmosphere. That is effectively like a cloud. It reflects the sunlight away from the surface of the planet, and that's so it has a cooling effect. Greenhouse gases, on the other hand, are invisible, but they have an effect on the amount of radiation or heat that is trapped near the Earth's surface. So aerosols have a cooling effect, greenhouse gases have a warming effect, and they battle it out together. So this led the IPCC to make a couple of very strong conclusions. So one is that human influence on the climate system has been detected in the atmosphere and in the oceans, and in changes in the global water cycle, so the things like floods and droughts, reductions in ice and snow, in global sea level rise, and in changes in some extreme events, particularly high temperatures. And the final conclusion there was that it's extremely likely, which is more than 95% confidence, that human influence has been the dominant cause of the warming that's been observed since the mid-20th century. That warming cannot be explained by natural factors alone, such as sunspots. Okay. Let's go down from the global scale to the Australian scale and see what's been happening here. This is a plot of temperature anomalies, again, relative to the period 1961 to 1990. So all the blue bars here over time represent cooler than average conditions. The warm bars represent warmer than average conditions. And you can clearly see there's been a warming trend of almost 1 degree since 1910, and 2013 was our warmest year on record. And some of you might remember that January of 2013 was extremely hot. And even this year, we had that heat wave of, I think it was 4 days in a row over 41. So that was again, quite extraordinary.
I blame the tennis.
Indeed. Yeah. In terms of the patterns of warming across the continent, it's a bit patchy. So we can see in the darker red colours, greater rates of warming. So these are in degrees Celsius per decade. So most of the warming has occurred in the, I guess, the south and the east. There's actually a little patch of blue up here, which is cooling. And that seems a little bit strange in a warming climate, but you do get these. And there's a very good reason for it. And that is that there's been a big increase in rainfall in the dark green in the northwest.
I thought you were going to say Gina Reinhardt.
Not quite. It's pretty much a line where she's having a lot of activity. But the dark green indicates where there's been an increase in rainfall, and you can imagine where there's more rain, there's more cloud, again, not allowing the sun to come in as much, and so there's been a cooling there. But over the rest of the continent, in the darker orange and yellow colours, there's been a drying, so particularly in the south and the east, and we know that included the 13-year drought from 1997 to 2009. In terms of the effect of changes in rainfall and temperature and how that influences fire weather, we have seen an increase in fire weather in the last 40 years or so, a period over which we have reliable climate data. So we've looked at some 38 sites that have reliable daily temperature, rainfall, wind speed and humidity data, which goes into a fire weather index. And at 16 of those 38 sites, we've seen an increase in the fire weather. And the extreme fire danger days have increased at 24 of those 38 sites. The largest increase is occurring in spring and autumn, and that means a longer fire season. And turning that around, it means there's actually a narrower window for controlled burning of fire to reduce the fuel load. So it's been quite challenging. So that's the past. Yep.
Kevin, things like the big fire that was down the open cut
Yes.
and burnt for a month, would that have a visible impact on any of your charting to the effect that of all that smoke that was generated and all the emissions that have come off that, so that will be something that you can point at in future time and say that event or the fires that we had a few years ago through King Lake and all through there, are they events that have a marked impact on the annual result?
I can't give a clear answer on that one. It's not my area of research, but I suspect that the fires that occurred back in 2009, the really big ones, they probably would have some sort of a signature in the amount of carbon released from the Australian landscape. There's a lot more burning that goes on in the northern part of Australia every year. And I think that is probably the dominant contributor to carbon emissions from fire in Australia. The one from the Morwell open cut, I suspect that probably didn't produce as much in terms of carbon release. And I was just reading this morning that was likely to have been caused by a faulty power line where the two backup systems didn't work. So, interesting. So we've talked a lot about the past and the possible causes of past climate change. What does that hold for the future? Well, what the IPCC says is that there's likely to be continued production and increase in greenhouse gases, which will lead to further warming and changes in the climate system. We're expecting a global warming of around about 0.3 to 4.8 degrees Celsius by the end of the century, and it very much depends on the rate of increase in these greenhouse gas emissions. And while this diagram is probably a little bit hard to see, this is actually the temperature, so the warming in degrees Celsius. This is over the historical period, that warming that we have seen, and then going out into the future. The low curve here is for very low rates of greenhouse gas emissions, and that only gives us a warming of about 0.3 of a degree with a range of uncertainty, because there are a number of climate models that are simulating this. Whereas this high curve here is for very high rates of emissions, and that gives you the warming of almost 5 degrees by the end of the century. We're not sure how greenhouse gas emissions are going to track. There's a bit of crystal ball gazing that's going on. It's based upon various different assumptions about things like population growth, economic development and technological change. So any one of those particular emission scenarios is plausible.
Have you plotted a curve which is business as usual? Whatever we're doing now, but just no change to the worse and no change to the better?
Yeah, unfortunately business as usual is the high curve. That's what we're tracking. We also expect with that warming for there to be further sea level rise, or a rise of between 26 centimetres and around about 1 metre by the end of the century. Again, depending on the rate of greenhouse gas emissions. We expect heat waves to occur more frequently, of course, and perhaps in a longer duration. More extreme rainfall events. Not only globally, but particularly over Australia in some recent work that we've been doing. And the key conclusion is that slowing the rate of climate change will require fairly substantial reductions in greenhouse gas emissions. So that would be effectively to get us from this high curve down to the low curve. Yes?
Just a question, with the extreme rainfall over most of the mid-latitude,
Yes.
land masses and whatever, that makes a bloody mockery of Flannery's effort with what was going to happen up in Queensland. He said they would never get bloody water up in there for another 20 years or whatever it was.
Are you talking about the Ord River system, or?
No, the floods and stuff that they had up in Queensland, that was after Flannery made his pronouncement that
It was never going to rain again.
never going to rain again in Queensland. That does really tremendous things to credibility.
That's a political curve, right?
So again, I guess you've just got to be careful where you get your information from. The interesting thing about some of this, which I'll talk about a little bit later, is that even where we find decreases in annual average rainfall, the intensity of the extreme daily rainfall events still goes up. It kind of seems bizarre, it seems counterintuitive. How can you get a decrease in average rainfall but an increase in the frequency of flooding? And the way to think of it is longer periods between rain events, but when it does rain, it's more intense.
Being realistic about the future, how much effect, like let's put it this way, if Australia didn't produce any greenhouse gases, how much effect would that have on the world situation?
Australia produces about 2% of the globe's greenhouse gas emissions.
Yeah.
So in a physical sense, it's not a large contribution, but then it starts to get into the politics, and I'll show you a statement later, which is it really requires a global effort to try and reduce emissions. So our emissions are very similar to what's produced by France or England, and if countries like that were to say, well, our contribution is relatively small, we shouldn't have to do anything about it, I think that there's a real political dimension to it.
If you did a parameter squared, Australia wouldn't even rain.
Yeah, quite possibly. That's right. That's right. Yes, yes.
So by keeping its population low, in effect is keeping greenhouse gases, so we're maintaining a lifestyle by keeping our population.
Yeah, except that the projections, of course, are for further population growth in Australia. Yeah.
You know what I mean? It all depends how you do the statistics. And most of them are per capita.
Yeah, per capita, Australia's right up there in the top five.
Yeah.
So,
But the top three emitters were America, Russia, China.
yep, that's correct. Yep. So,
Is the elephant in the room population increasing in the world?
Yes.
yes, and I'll talk about that. We'll talk about that a bit later. It also depends on how efficiently people are, I guess, using energy and water and so on. And so this comes back to the per capita, we produce a large amount of greenhouse gases.
Is that something that America doesn't want to talk about? Is that was a topic that came up and was cut pretty quickly?
Yep, population growth is a big issue, but so is economic development. Yep.
And in Australia, because it's mining and agricultural, that's why our emissions are high.
That's right, and we're mining brown coal, which is one of the dirtiest sources of coal, with very high amounts of carbon dioxide.
You've got to burn 2/3.
Yeah, I'll talk about nuclear later too. Okay, so what do we expect in Australia? We expect a warming by the year 2030 of about half to almost 2 degrees Celsius. And you just remember we've had a warming over the last 100 years of about 0.9 of a degree Celsius. By 2070, the amount of warming depends on whether on a low emissions path or a high emissions path. If we're on a low emissions path, it's a warming of 1 to 2.5 degrees. If we're on high emissions, it's a much faster rate of warming. We expect a greater rise in the maximum temperatures than the minimum temperatures in southern Australia, and the opposite in northern Australia, with more hot days and fewer cold days, as you might expect. And just to give you a sense of the amount of change in, let's say, the annual number of days over 35 degrees Celsius, it's a fairly busy graph. I might just orient you with, let's just say, look at Melbourne. So Melbourne, 9 days over 35 currently. So that's the average from 1970 to 2000. So an average of 9 days over 35. When we go out to the year 2030, for sort of a mid-range emission scenario, it increases to between 11 and 13. If we go out to the year 2070 for a low emissions path, it increases to 12 to 17, and for high emissions between 15 and 26.
With the low emission path, why is there such a high number, 12 to 17, where 11 to 13? Oh, sorry, 2070. My apologies.
Yep, is that okay? Yeah, it's a bit of a tricky graph because there's two columns for 2070. Yep. And so you can see some fairly substantial increases in the number of days over 35 for what, on average, is a relatively small change in the average temperature. So a small change in the average has a big effect on the extremes. In terms of future changes in rainfall for Australia, this is just showing the percentage change in these colours here, where yellow through to red is a decrease and green through to blue is an increase in rainfall. There's not a lot of blue on that graph, on that map. So what we're finding is that in winter and spring, the darker orange colours indicate a greater likelihood or larger decrease in rainfall is being expected. And the stippling here, these little dots, indicates where 2/3 of the 23 climate models that we look at agree on a decrease. So we have high confidence on a decrease in those regions. Not as much confidence in the changes in summer and autumn, and the rates of decrease are smaller. So frankly, there's a bit more work to understand what's going to happen in parts of, say, northern Australia in summer, because that grey is indicating not much change or a large amount of uncertainty. In addition to those changes in average seasonal rainfall, we expect evaporation to go up. And as you can imagine, the combination of lower rainfall and more evaporation has a big effect on the flow of water into rivers, for example. And, as I mentioned before, an increase in the number of extreme rainfall events, even where the average rainfall goes down. In terms of fire weather, as I said before, we've seen a historical increase in fire weather. We expect further increases in future. This is a table showing the percentage change in the number of days with either very high or extreme fire danger. If we just focus on what's called extreme, which is the days would be declared as a total fire ban, by 2020, for a low rate of global warming with low emissions, we expect a 5 to 25% increase in extreme fire weather days, but a 15 to 65% if we're on a high emissions pathway, and much larger percentage increases as we go out to the year 2050. So this is something that the fire management agencies are taking quite seriously, because it does have implications for how you manage fuel load and the sort of resources that you throw at it. And of course there was the Royal Commission into the 2009 bushfires, and that came up with 67 recommendations to how you would try to manage both the current risk and the future risk. In terms of tropical cyclones, our modelling suggests that there may be a decrease in the frequency of tropical cyclones, which is good news, but those that do occur would tend to be more intense, more severe, and possibly moving further south. So there's a concern that some of the cyclones may start to affect places like Brisbane and the Gold Coast, and there's a lot of infrastructure there that's exposed. Now, those projections that I just presented to you there were based upon work we published in 2007. We're in the process now of developing a new set of projections that will be released later this year, and that's based on work that we've been doing for the past 18 months. So keep an eye out for that. So that's just looking at the projected changes in climate and weather. What does this mean in terms of impacts, adaptation and vulnerability? And a couple of reports were just published by the IPCC just 2 months ago. So this is looking at, firstly, I guess, global and sectoral aspects, and then volume 2, which is looking at regional aspects. And I'll just try to summarise some of the key conclusions from those reports. Firstly, the conclusion is that climate change is a clear and present issue. It's something that is happening now. It's not something that will just happen in the future. And it's expected that damages from a large range of recent climate-related extreme events reinforce our knowledge of vulnerability. Even in nations that are developed and have high capacity, like Australia and the US, are still vulnerable to the effects of extreme weather. And we've seen a number of observed impacts of climate change. So, for example, in the oceans around Australia, we've seen impacts on a range of different organisms. We've also seen negative impacts on crop yields, particularly during droughts. And these impacts have combined with other stresses such as population growth, as we mentioned before, and other things such as development on coasts, which again enhances our exposure to extreme events. So we are quite vulnerable to climate change and these trends that we've been seeing. Another conclusion was that recent climate extremes reveal significant vulnerability in ecosystems and in human systems. So we've seen coral bleaching on the Great Barrier Reef, but now we've started to see it off the West Australian coast on the Ningaloo Reef. We've seen flooding across much of eastern Australia. We've seen many deaths during heat waves. So back in January 2009, 374 excess deaths over what we might have expected during a heat wave. And just earlier this year in January, in that 4-day heat wave, there was about 180 excess deaths. We're seeing deaths related to bushfires as well. So 173 deaths on Black Saturday 2009. And substantial economic losses during droughts, sometimes equivalent to 1% of GDP, or about $1.6 billion. So droughts also have a big effect, even though they're extreme, but they sort of are slowly emerging over many months. And the key risks in future are likely to be on things like human health, critical infrastructure, food security, water resources, and marine and terrestrial ecosystems. And a key conclusion is that increased warming increases the chance of irreversible impacts. So we really do need to consider how we manage those impacts. An example at the global scale for agriculture is just shown here for, this is for crop yields. It's a fairly busy diagram, so I'll just indicate this is a percentage change in yield as projected. So we've got percentage changes from 0 to 100%. In blue, we've got increases in yield, and in the yellow through to brown colours, we've got decreases in yield. And in the near term, 2010 to 2029, there's a relatively even balance between increases in yield for a number of regions and decreases in yield. And as you might imagine, there'd be places in, let's say, the Northern Hemisphere, which are currently too cold for growing many crops. Global warming and a bit of an increase in rainfall, that's actually going to enhance the productivity of many crops. And high levels of CO2 actually have a fertilising effect. So they actually enhance the photosynthesis, the productivity of many crops. So it's no surprise that global warming can produce some benefits, at least in the short term. But as we go further out in time, those benefits tend to decrease and the losses tend to increase, particularly in tropical areas where it just gets too hot to grow some crops, and in other areas where there are big decreases in rainfall projected. In terms of future impacts in Australia, the conclusion is that without adaptation, changes in climate, sea level and the atmospheric CO2, that's the carbon dioxide, and acidification of the oceans. As the oceans absorb higher levels of carbon dioxide from the atmosphere, they become more acidic, and that affects not only coral reefs but other marine organisms. So substantial impacts on things like water resources, coastal ecosystems, infrastructure, health, agriculture and biodiversity. I mentioned before that over many parts of Australia we expect a decrease in rainfall and an increase in evaporation, and that can actually be quantified using what they call rainfall runoff models. So runoff is the amount of water that then flows over the surface. And so we've got some estimates of runoff for a 1 degree increase in global warming. And the mid-range or median estimate is shown here, where in red we're looking at decreases in runoff from 5 through to 30%. And that occurs around much of the Australian coastline. Some areas of possible increase up in the very high, the very northern parts of the country. But if we look at the results from the wettest of the climate model results, so we're looking at some 50 different climate models from around the world now, the ones that give us the biggest increase in rainfall suggest that some parts of the country will indeed get increases in runoff. But interestingly, down here in parts of southern Victoria and certainly parts of southwest WA and northern Tasmania, even the best case scenario is for a decrease in runoff. And so that is of concern. And then if we move to the case where we look at the models that give us the biggest increase in evaporation and the biggest decrease in rainfall, the net effect is some very large decreases in runoff into our rivers and into our dams. So that's something that will need to be managed.
Quick question over here.
Sure.
Given that the temperature's rising by whatever, 4 or 5 degrees, would the amount of would the atmosphere become more sort of more moisture laden?
Absolutely correct.
And so, what, it's just going to sit there forever without rain? Or
No, so
or?
it's a great point. So when you warm the atmosphere, you actually create more evaporation.
Yep.
It does put more moisture into the atmosphere, and it leads to more rainfall. The big question is, where does that rain fall? And all of our climate models indicate that it's not going to fall uniformly over the globe. There are areas in the higher latitudes, so toward the poles, that tend to get more rainfall. In the middle latitudes, like where we are, and South Africa and parts of South America, and the equivalent, say, in parts of northern or parts of central USA, they become drier. And in the tropics, there are also places that become a bit wetter. So unfortunately, that extra rainfall that's produced doesn't fall uniformly over the globe. But it's not all bad news. As I mentioned before, there would be some benefits in some regions. So we find that there would be reduced winter deaths. So as it gets warmer, there's less stress on a lot of people, particularly the elderly. Reduced energy demand in winter for heating. Increased forest growth, particularly in cool regions, and a potential increase in spring pasture production. So these are some areas where there will be potential benefits. But we do need to adapt. So if we did nothing, there would be significant impacts. And I really want to focus on not the sort of the doom and gloom, the bad news. I want to focus on the fact that there are solutions to this issue, and they're being thought about quite seriously. And adaptation is already occurring, but mostly at the sort of planning conceptual level. There's some really good examples of it in terms of sea level rise planning around our coasts. So most of the coastal councils are incorporating sea level rise in their planning. And also in terms of water resources. So we have a Murray-Darling Basin Plan, for example, which is going to try to manage a reducing water resource. But there are some real constraints on what we can do in terms of adaptation. There is some uncertainty and an absence of consistent information that's available, limited resources, both financial and also in terms of ability to change society's behaviour. Limited integration across different levels of government, from local government through to state through to federal. And a lack of binding guidance on principles and priorities. So what things, if you've got limited resources, limited amount of money, what do you target? What are the highest priorities? And you'll get a lot of debate about that. And different attitudes, both community and individual attitudes towards the valuation of risks. So what really matters to people? So I'll just give you a sense of some of the significant impacts and the scope for adaptation. And let's just start with coral reefs. There are some areas like this where it's actually going to be really difficult to avoid significant impacts. And so the IPCC has come up with tables like this, which I'll show for a number of sectors, which indicate that for current levels of adaptation, the present risk is somewhere between low and medium. It's actually already quite significant. As we move forward in time to the near term, where we think there might be about a 1.5 degree warming, we see that the risk increases to beyond medium to heading toward high. And then as we move further into the future, depending on whether we're warming by 2 or 4 degrees, there's much, much greater risk for our coral reefs. And if we were to incorporate some high rates of adaptation, the bars shift back to the left a little bit, but not much. There is a limited scope for adaptation to protect many of our coral reefs. They're very sensitive to a warming of about 1 degree. So once you get beyond about 2 degrees, the coral reefs do start to bleach and die and don't recover.
What's having the greatest effect on the reef? Climate change or the crown of thorns? Crown of thorns
is definitely having an effect. Climate change is having an effect through the warming of the oceans. And one of the adaptations... at the moment, it's probably crown of thorns. We had coral bleaching episodes back in 2002 and 2008, if I remember correctly, and that did lead to some death of the coral reef. And what they're really talking about in terms of adaptation here is trying to reduce the other stresses beyond climate change to make those reefs more resilient. So getting rid of the crown of thorns starfish will be one of those. Reducing overfishing is another. Reducing the amount of nutrients that come from agriculture and go into the The coral lagoon would also be another measure to reduce other stresses to enhance resilience.
How significant is the runoff of phosphates into the ocean?
It is quite significant, particularly after heavy rainfall events. You can see those plumes of sediment and nutrients affecting the reef.
Is there a lot of effect from ships emptying their bilge water and whatnot there going down those shipping lanes?
Yeah, I'm not sure about that one. Not sure.
Because I think where they take on, say, ballast in a tanker when you're running empty, where they take the water from could have Christ knows what in it, and then be emptied as they get closer to fill up there.
Yeah, that's true. I mean, of course, there are regulations around not doing that, but...
Oh, yeah, that regulations mean nothing to us. These things are under the flag of convenience.
So moving on from coral reefs to mountain ecosystems, and of course we expect warming on mountains and a reduction in snow cover. So there are a number of species that need snow to survive, like the mountain pygmy possum. So at present it's considered that there's again between sort of low and medium risk for many of those species. As we move further in time, in the near term, that risk increases as you would expect, and with further warming, even greater risks. If we incorporate high rates of adaptation, it again brings those bars back a bit, but not to the extent that it's going to protect many of those species. So we will lose some species from our mountaintops.
Much better than the outcome for the reef, though.
That's true, it's a little bit better. So there might be scope here for creating what might be called migration corridors. So for some of the species, if we can create a pathway that allows them to migrate or even relocate them physically, that might be one way of helping to preserve them for a few years at least, buy some time. Now with water resources, there is some scope to have some really positive benefits for reducing the risk. So it's considered that currently our water resources, again, have a bit of a sort of a low to medium risk. We already have seen, particularly at the end of the drought in 2009, many of our dams were at very, very low levels. Of course, we had 2 really big rainfall years after that, and that topped up many of our dams. As you'd expect, as we move into the near term, the risk increases a bit, and further into the future, it increases a bit more. But with some of the adaptation strategies we have, there's scope to really significantly reduce those risks. So, for example, not only enhancing our water use efficiency, but also just behavioural change. You know, we've seen the effectiveness of water restrictions, and in some cases, for example, in Brisbane, after they took away their water restrictions, there was actually sustained reduction in the use of water. So it actually changed behaviour permanently. So that's really encouraging.
So with that water like that would help with irrigation too then?
Indeed, some more efficient ways of irrigating, putting some of our open channels into pipes to reduce the seepage from below and the evaporation from above.
What about the deforestation, the McDonald's beef burger problem with deforestation and increased cow production of methane? How significant is all that as a combined?
Globally, it's a very significant issue, and I'll make mention of that later. So deforestation changes the surface from like a dark green colour to a much lighter colour, which might be pasture or something else, and that increases the reflectivity of the surface. And it also takes away, I guess, the lungs of the planet, which is absorbing some of that carbon dioxide. So that does have a big effect.
So you're saying McDonald's is bad?
I'm not saying that. CSIRO is not saying that.
What's the effect of where you get the deforestation and they replace that with non-indigenous species?
Well, I guess that's happening quite a bit.
Palm oil and those sorts of things.
Yeah, I'm not sure as far as the atmosphere is concerned. As long as there is some vegetation absorbing carbon dioxide, that's a good thing. It's not a good thing for biodiversity, of course.
Sure. There'd be a lag in the growth rate of the renewed tree.
That's right, and I was told the other day that after logging forests in parts of New South Wales, where the regrowth has an effect on the amount of water that is yielded from the catchment. But in New South Wales, it's a lag of about 2 years. If you do the same thing in Victoria, it's decades. So quite a different situation. So deforestation also has an effect on water availability. Oh, sorry, yeah.
From a political perspective, are there countries that stand to gain from global warming in terms of their conditions will improve, their productivity will go through the roof and all that sort of stuff?
Yes, so in terms of the graph I showed before on crop yield, in the short term, I think there are some areas of high latitudes of the Northern Hemisphere, like say, parts of Russia, Canada, parts of, say, Poland, which certainly would benefit. But as the warming proceeds, it does start to lead to some further complications. Yep. Again, so in terms of flooding, we have a medium exposure to that currently with current rates of adaptation, which of course increases over time. But with adaptation, we can reduce that risk of flooding. So better management of stormwater, for example, is one obvious way of doing that. Heat-related impacts and deaths, so impacts not only on the tennis and on our trains where the air conditioning fails above about 30 degrees. There's also scope for reducing the impacts on heat-related stress and deaths. There's medium exposure now, obviously increasing over time, but with adaptation, some very, I think, strong prospects for reducing that exposure. And I think we even saw it between 2009 and this year with the heat wave that occurred. There was a big reduction in heat-related deaths, and I think that was partly due to education of the public about looking after your neighbours, your elderly neighbours or your frail neighbours, and early warning systems. So warnings from the Bureau of Meteorology have become far more accurate, and they're putting information out a bit earlier so people can actually do something to prepare.
What political pressure is Australia putting on cities like Shanghai and Beijing to decrease the sea level, basically?
I'm not privy to that sort of information.
To decrease it.
Yeah. I mean, there are international negotiations that occur in December of every year.
Is it information or is it education or something? Is there any international correspondence or something going on?
Well, there's a conference of parties that's held every year, and all of the nations come together, and there's a lot of argy-bargy that goes on there, but I'm not privy to what goes on behind the closed doors.
We used to think Kevin would fix it, now Tony will fix it, so I rest it.
We shall wait and see.
In China, they're doing the 100 chimneys in 100 days reduction. Is that related to the global warming?
I'm not familiar with that. China, I must say, is putting in quite a lot of effort to reduce their emissions. So just one final one on fire, and the effects on ecosystem settlements and life. Again, low to medium risk at the moment, increasing over time, but a significant scope for reducing that risk through adaptation. And one of the things with wildfires is, of course, a bit of a controversial one, but maybe putting power lines underground to reduce the risk of those sparks causing fires. Fuel reduction burning, again, reducing the amount of fuel. Clearing areas around houses, building more fire-resistant houses, having bunkers and so on. So there's a lot of options for reducing risk there.
With the figures on deaths, Kevin, does that include people who are living in fire-prone areas and they know it and it's deliberate, so it's stupidity? Does that come into your calculation? How do you sort the wheat from the chaff?
Well, I guess one other lever that you can pull there is around planning regulations. Do you allow people to actually build in areas that are fire prone or flood prone for that matter? In a lot of our floodplains, there's a lot of infrastructure and people. Not a great idea, but previous planning regulations allowed people to build there, and so it's going to be difficult to move them out. But there have been examples after the Queensland floods where the government paid people not to re-establish in high-risk zones, and they moved further up the hill. And that affects insurance.
The back of my joint there in Baronia there where the fires came through there a few years ago and places were burnt down and all the rest of it and people died. And half of them weren't insured because they couldn't get insured, but of course the government comes and pays them out to get the vote and then they rebuild in the same place. So I mean it's a bit hard to put that death down to fire, that's down to stupidity.
Well, there need to be incentives for better planning and better behaviour. And I know that the government is actually talking with us at the moment because they're very concerned about becoming the insurer of last resort, because people are not often fully covered, if covered at all. and it often falls then onto the federal government and the state governments to some extent to carry that load. The government doesn't want to be in that situation, and so they're looking at ways of encouraging more investment in preventing these events occurring in the first place, or at least being better prepared.
Yeah, but when you say the insurer of last resort, that's if there's mass damage. If my house burnt down and I wasn't insured, I wouldn't be, the government wouldn't be coming to me with a last resort
Indeed.
check.
Kevin, where do natural disasters fit into all of this program? You know, Mount St Helens or other, you know, huge earthquakes, tsunamis?
So earthquakes and tsunamis are not part of this at all. I've not heard of any credible connection between climate change and earthquakes which cause tsunamis. No connection with the triggering of volcanic eruptions either. The only connection with volcanoes is that they have a cooling effect over 2 to 3 years if they're really big. Mount St Helens, I think, blew out sideways, so it didn't have a sort of a big upwards trajectory. But that cooling effect is taken into account in our projections of global warming.
Do you take it as a significant blip, or it's just a
They're pretty small blips. Yep, about 0.2 of a degree of cooling over 2 to 3 years.
Has there been any research done on the effect of seafloor spreading through the Indian Ocean and the Pacific Ocean as far as heat generation?
It doesn't create a lot of heat, no. And that would create a natural amount of carbon dioxide release, but it's much smaller than the what's being produced through burning of fossil fuels.
Another question, the pollution in the oceans, the plastics, these eddies of plastics, are they causing heating of the oceans as well?
Not that I'm aware of. Again, I think that would be a really small effect in terms of temperature, but of course an important effect for ecosystems.
Has there been any noticeable effect yet from the introduction of renewable energy sources?
Yes, I mean, particularly in Germany, I think they're now 20% renewables. And that's really helped them to get their emissions down. In Australia, it's a bit less than that, and I think our renewable energy target is about to be disbanded. So, having these targets actually provides an incentive for businesses, for the private sector to invest.
Because there's some, like you can say, you look on one hand, look at England, they said they've met their greenhouse gases emissions and they've lowered it to the Kyoto Protocols, but all they've done is exported their manufacturing to China. So it hasn't reduced
global emissions. Yeah.
So, there should be some better mechanism, shouldn't be at the, this is where the whole carbon tax comes very political, because it should be at the consumption level, not at the producing level.
Indeed.
I think that's similar to what Germany was doing too when they said no nuclear powers, but they still bring their power in from France, which has nuclear power.
So they're going down, but they're buying it from France.
Yeah, you'd hope as part of the EU emissions trading scheme that would be captured.
That's just cheating.
I think Germany's going to start some reactors up again anyway.
Yeah, I'll mention that later. Okay, so that was the second of the IPCC reports, and here's the third and final one, and I'll just quickly go through this. So this is on what's called mitigation of emissions. Mitigation in this context is reducing not only the sources of the emissions, but also enhancing the sinks. And what I mean by sinks is some of the mechanisms for absorbing carbon dioxide and other greenhouse gases from the atmosphere. So one example of that is planting more forests. Another example of that is enhancing the ability of the ocean to absorb carbon dioxide.
Like planned forestation, where you actually grow pine trees to use for construction, that locks the carbon up in the wood.
Yes.
And then you grow more.
Yes.
Is that what you mean by that?
Yes, that's right. So once it's locked up in the wood, that's a good thing. You're not burning it.
Yeah.
And then, plantation timber, where you're continually sort of harvesting every 20 or 30 years is typically what's being encouraged. But that has all sorts of other negative. Indeed. So that it's a high risk asset, for not only for fire but also for drought, where the trees may die.
Are there special trees that are preferable to other trees? For example, the gum tree is burning pretty easily. Are there better trees or more safer trees or something? Is there a selection?
Well, I know in Australia that the typical plantations are either blue gum or pine trees. I don't know whether they've actually factored in climate change as a risk factor, though.
With regards to mitigation, you talked about all these things we could do. What's the population control. That's the one we have to hit.
That's right.
We've got to stop people producing children. No, I'm quite serious. This is what we've got to do. We've got to say families can only be a certain number of children.
Yeah, like the
Or
Chinese
we're
have
not going
done
to
that.
stop it.
Yeah, they've tried that in China, of course. Yeah.
No, but
Decent war.
I've lived in the tropics, and okay, we've come up there, we've decreased infant mortality, which was the natural birth control. They haven't gone to the other side of the equation. So you've got a lot of those nations where you look at their average age, it is very young.
Yeah. So, the projections for population growth are pretty scary. So if that's going to be hard to turn around, then we need to become more efficient with the way we use our resources.
But that's not considered by the IPCC as an option.
Yes, it is. It is mentioned. Yep. It talks about.
How's it going to work? Do they think they can make people have less children?
No. So the IPCC identifies it as an issue, but it doesn't say how you would address it, because this is about climate change, not about population growth. It indicates that both economic development and population growth are the two biggest causes of increasing emissions.
India's got 1.3 billion people now. India, almost China, basically, is big.
Yep. Okay, so, and the second point there is that we need a collective effort, as I mentioned before. It can't be done just by individual countries determining whether they want to opt in or opt out. So that's the political dimension. They also concluded that climate policy can be informed by lots of different information about risks and benefits and uncertainties. Some of it's difficult to measure, so we don't know everything. For those that say the science is settled, they're absolutely wrong. There's some stuff we know really well, and I'm trying to convey that to you tonight. There's some stuff that we still don't know well enough, and that's why we still do research. But we do need to consider the possibility that there will be big events that have low likelihood or low probability. And risk is the combination of impact and likelihood. So something like, for example, an asteroid hitting the Earth. Big impact, very, very, very low likelihood. But do we ignore it? No. We've got to consider things like that. So, for example, in the climate change context, the rapid melting of the Arctic ice sheet. Low probability in the next 100 years, but a big impact if it did occur. So we don't ignore it. And the final one there is just the design of climate policy is influenced by how individuals and organisations perceive risk and uncertainty. And an example of that is our preferences for not wanting to change. So that there's a large sector of the population that's just happy with things the way they are. They're afraid of change, and they don't want to change. And that's real, and we grapple with that. Some people are very risk averse. They're not risk takers. They're just not wanting to take any risks. So they're almost on the opposite end of the spectrum. So we must do something about it. And also the importance that we place on the near term versus the short term. Versus the long term. And often that's framed in terms of intergenerational equity, or what sort of a world our kids might inherit.
Have the alarmists not caused the grief and the bulk of people not to want to change because they're so extreme in their perceptions of what the future holds, rather than why don't we hear more from the CSIRO, or is it a case of you guys, despite all the work you've done, aren't attractive to the media and you don't get the same sensational headlines that Mr. Flannery or somebody else might get? We all accept, I think your opening statement said that we all accept that there is some change occurring, but I'm not about to tell you that climate change is as significant as these other people are trying to impose on it. It's almost like it's personal agendas for them. There's some substance in what they're saying, but it's so far-fetched. Well, that's how we perceive it.
Yeah. There's a lot of vested interests. Yeah. So there's a lot of vested interests and agendas that are being played out. The position of CSIRO is in the middle. We're just talking about the evidence and trying to indicate our level of confidence, whether it's high or low, and what we think the solutions are as well. There are other players out there that will tell you it's not an issue, and then at the opposite end of the spectrum there are those that are saying it's an incredibly bad problem and we're not doing enough. So as I said at the very beginning, you've got to try and sort out, where the truth really lies. And I'm trying to convey to you tonight what we do know with a high degree of confidence.
I appreciate what you've said, sir.
I think one of the criticisms is the tax, the carbon dioxide tax, which may possibly not have a big impact, would have a big impact if you raise obviously the tax for maybe 20 million people and 10 million tax-paying people. Does have an impact on globally where other populations are, as I said, over 100 million or something. I don't know.
You don't have much control over it.
No, you don't. So you
control over what happens in Australia.
Yeah, when you pay tax, of course, and that's what people don't like. It goes into the purse straight away. What impact will it have if I pay?
By definition,
Others don't pay.
but by definition, a carbon tax is a consumption tax because everything you make is done through a carbon process.
Pretty much.
Right.
So as we said before, Australia produces about 2% of the global emissions. If we're able to reduce those emissions, it makes a contribution to the global effort. So if Australia did nothing, that would probably justify other countries of equivalent size in Europe not doing anything. And I think of all of the countries with about less than 2% of the global emissions, that adds up to 25% of the emissions. So lots of countries add up to a substantial amount of the global total.
What about going the other approach and tackling the big boys?
That's happening in parallel. That's what happens in these international negotiations.
Because I think in the developing countries where they've gone through their very high industrialisation phase, that they have a perfect opportunity to put in the newer technology.
They do, and there's a thing called a clean development mechanism, which provides funding for developing countries to actually do exactly that.
If you look at Victoria, there hasn't been a significant power station built since the 90s. And Lightning B was the last major brown coal power station. The closing down of Alcoa means they're probably not going to need one for another 10 years.
Yeah. I suspect we're going to need what's called a peaking power station to deal with the peaks in energy, because we still have brownouts and blackouts.
Yeah, they've been doing gas turbine.
Yep.
Yeah, and
Like the one at Newport.
Basslink.
But Basslink drops out when it gets too hot.
What about small things like using LED lights as opposed to incandescent?
Absolutely,
is that
absolutely.
a noticeable thing, a worthwhile thing pursuing?
Oh, absolutely, and there's incentives to do that. So there's a lot of things that we can do in our own homes in terms of reducing, or improving energy efficiency, both technological and behavioural, and the same thing for water consumption as well.
And just increasing the price of the commodity, is that one way of encouraging people?
So yeah, there's carrots and sticks, I suppose. So you can send a price signal to make bad things more expensive, but you can also provide money to encourage people to take up new technology, because some of this new technology is more expensive. I remember when the compact fluoro globes came out, and they were about $10 each, sometimes more than that, whereas the old incandescent globes were 50 cents. People would look at that and just go, well, I'm not buying the more expensive one, even though it lasted longer and consumed less energy. So there's a real challenge there to get people to think long term.
One of the problems with that new lighting regime is the fact that we've actually created a new pollution problem called electromagnetic pollution because of the poor standards of the equipment it's made to, and we as radio emitters all experience it.
Okay. So you experience that as interference?
Yeah, broadband hash.
Okay. Right.
I don't think you're going to worry about us, Bob.
Okay, so which sectors of the economy are the main culprits of producing greenhouse gases? Probably no surprise. It's mostly the energy supply sector. Also,
that's a misleading photograph. That's all like steam.
oh yes, of course. Yep.
But it looks good, doesn't it?
Yeah, that's right. The invisible gas is the greenhouse gases. Yeah. Industry 30%, transport 11%, and buildings 3%. And as I said before, without significant efforts to reduce those greenhouse gas emissions, we expect emissions to grow further into the future, driven by global population and economic activities. Yep.
a question on the transport. How much of that is air travel?
I don't have the figures at my fingertips, but it has been documented in the IPCC report. I think it's mostly land-based travel though. And so the IPCC has looked at different scenarios, different possible trajectories of these emissions over time. And this graph is just showing the annual emissions of greenhouse gases in gigatons of carbon per year over the 21st century, based upon different assumptions about technological and behavioural change. And the scenarios that keep the global warming below 2 degrees above pre-industrial, so the Industrial Revolution was around about the year 1750, so 2 degrees above that level, have concentrations of this CO2 equivalent of around about 450 parts per million. Now, CO2 equivalent is the effect of all of the greenhouse gases, including methane and nitrous oxide and so on, expressed as an equivalent of one gas, which is carbon dioxide. It's just a convenient way of expressing the effect of all of those gases. And you can't read this, I'm sorry about the quality of that diagram, but it's this orange curve here that gets us around about 450 parts per million, so below 2 degrees warming. So we would have to follow a trajectory which bends this curve back around and finishes up here if we're to get to 2 degrees global warming. So as I said, we're currently on this trajectory here, heading upwards, so it requires quite a significant turnaround.
How do you establish data from the 19th century, for example, temperature?
There are some temperature records from the 19th century, but fairly sparse globally. We also have records of temperature from little bubbles of air trapped in ice from Antarctica and from the Arctic. And from those bubbles of air, you can extract the gases, including greenhouse gases, and you can actually put a timestamp on it. So that's to try to avoid a 2 degree warming. Scenarios that reach 650 parts per million are unlikely to keep the warming below 2 degrees. And an example of that is this one here, this RCP 6.0, the purple curve. So that one doesn't quite get us below 2 degrees of warming. And 2 degrees is commonly referred to as what might be thought of as dangerous climate change. And the way we're going with projections just out for the next 5 years or so to 2020, we're heading toward a long-term warming of at least 3 degrees. That's going to be almost impossible to avoid. So that's what we need to just keep in mind. Another conclusion from the IPCC is that delaying action to reduce emissions makes it much harder and more expensive to shift to these low emission scenarios in the future. And it reduces the options for trying to keep below 2 degrees of global warming. So early action is beneficial and cheaper. And reducing emissions has other benefits just beyond climate change. It produces reduced costs for achieving air quality and energy security objectives. And it has significant benefits for human health and for ecosystems. So even if you put aside the climate change benefits, there are all these other benefits that come out of it as well. So let's look at some specific sectors, just one by one. This slide is just looking at infrastructure and energy. And so the conclusion here is that infrastructure that locks societies into a high emissions pathway, so you might build another power station and it's coal-fired in the Latrobe Valley using brown coal. That locks you into some infrastructure that has very high emissions in future. Not such a great thing. And it's really costly to change. So the actions that we take today have big impacts for the long-term future. So there's a lot of things like roads and bridges and other assets that have a long lifetime.
Kevin, why is Germany closing all their nuclear power plants and putting brown coal generators in place?
That surprises me. Is that true?
That is true. That was in the paper this last week.
That sounds bizarre given the effort they've put into renewable energy. Clearly they don't want nuclear.
A lot of their electricity is
I
coming
was
from France.
quite stunned by it.
They brown coal very high sulphur prices.
That was reported in a number of places, paper on the internet.
Okay, I'll have to follow that up because it really surprises me. So in addition to the type of infrastructure that you employ, Improvements in energy efficiency have a real benefit for reducing emissions. And also behavioural change, just the sorts of things we do with our light switches and the level of heating that we have in our rooms and so on. And we were talking about renewables before, so many renewable energy technologies have demonstrated substantial improvements in performance and cost reductions over time. And they're at a scale now where we can actually roll them out over very large areas. So wind power is one example of that, but solar is another.
Yeah, just on solar power, there was a statement made, not too sure by whom, that it takes more energy to produce the solar panel than it does what it will produce in its lifetime. So is it worthwhile making the thing in the first place?
Yeah, I'm not sure if that's the case. It would surprise me if that was the case. But
that was the case.
Yeah, I know it's been really challenging in terms of the solar technology to make something that converts the light efficiently into energy.
They're up to 13-15% efficient.
Yeah. University of New South Wales was a real leader in that, but I think Germany and now China's able to produce these things really cheaply.
One of the things they've got to do, okay, if we get solar, is how you convert that into an energy source that you can use 24 hours a day and storable. You can put into your car, and that's what we haven't got. We haven't got that energy.
Oh, there are some smart batteries around. Phase change.
If we're going to have Central Australia, nice big solar cell. How do we get that energy so we can use it here in our cars?
Well, and then there's another issue there, which is the transmission.
Yeah, and that's why you can't use light. You can't use power lines. You have to use something else.
Yep.
You've got to store it.
Yep.
You still want energy when the clouds are over.
That's true, and the same thing sort of applies for wind energy. It only works well when it's windy.
That's why they're not really the answer at the moment.
They're not the whole answer.
You're relying on coal being there to take it up.
Not necessarily coal. So when we talk about reducing energy, reducing emissions from energy, there's a portfolio of solutions. So renewables are part of that. Nuclear might be part of it. Carbon capture and storage, where you capture the carbon and pump it underground, that's another part of the solution. Bioenergy, there's a whole range of different products that all together provide some reductions in emissions, but there's no single solution, no silver bullet. Okay. Just moving on from energy, I've talked about nuclear. The deployment of nuclear has actually declined quite a bit since the 1990s. But having said that, it does provide an option for providing low emissions baseload power. So this is the sort of constant power, but not the peak power that we need occasionally. But there are a number of barriers, and so in terms of storing the waste, nuclear proliferation, and society's attitudes toward it. So that's a challenge. But I think that's going to come up in Australia again pretty soon. We have the uranium, of course, and the technology now with these Generation 4 reactors is pretty good, and the storage is also pretty good.
Thorium.
Yeah.
Thorium reactors are the future.
And with a lot of our coal-fired power plants, they could be made more efficient, more effective, and as I mentioned before, carbon capture and storage. So pumping some of that carbon dioxide underground and storing it there rather than releasing it into the atmosphere. Yeah, so if that's right, if they were going to be producing more coal-fired power stations, you'd absolutely hope that it would be capture and storage. Yep. In terms of transport, a lot of technical and behavioural solutions there. And so there's the options to reduce demand. Reduce the final energy demand by 40% by the year 2050. So this is another sector where big savings can be made. And especially for economies where there's a large rate of urban growth, public transport also reduces emissions. In the building sector, building codes make a big difference, and having appliance standards, so for a lot of our dishwashers and fridges and so on, having that that star rating, again makes quite a big difference to the amount of energy consumed and the cost of energy that we pay in our bills, as well as reducing emissions. And also retrofitting buildings. In some of our renovations, there are also options for reducing the amount of energy consumed and hence the emissions of greenhouse gases. Yeah, and wind powered. Yeah.
Airtight buildings and obviously double glazing or triple
Yep,
glazing.
double glazing. Double glazing, triple glazing is still very expensive in this country. It's cheaper in the cooler climates.
Airtight buildings will save a huge
Yep.
amount of energy.
Yep, indeed. And not too expensive either. But beyond that, behavioural change, so lifestyle, cultural and behavioural change also influences energy consumption. But there are still strong barriers to taking up these market-based opportunities. So for example, there's still inadequate access to information and to finances. So for example, cheap loans to install, say, solar panels on your roof, or put in pink bats, dare I say it. And in the rural sector, we talked about forestry before. There are options for reducing emissions from forestry. So one is to put more forest in, so that's afforestation. Sustainable forest management and reducing deforestation. So again, the forests are the lungs of the planet. In agriculture, the most cost-effective options are better cropland management, grazing land management and restoration of the soils. And I know the Coalition is very keen on enhancing the carbon content of soils, which is again a sink for carbon dioxide. And this is the final slide actually. We've heard a lot about policy, so there are emission trading schemes such as in the EU. I think there's one in California as well. There are various schemes in various regions of the world, and they've been leading to some reductions in emissions, but the price on carbon, which is driving this, has actually been coming down instead of going up, so it's been quite challenging. And in some countries, including Australia, there have been tax-based policies aimed at reducing emissions, and it also helps to break the link between economic development and the production of greenhouse gases. If you can sever that link, you can still have economic growth and reduce emissions. Also, they're looking at the reduction of subsidies for greenhouse intensive activities in various sectors. So, for example, our fossil fuel sector, the coal mining sector, does get a lot of subsidies from government, and there are questions around whether that's a reasonable thing to do. And beyond the public sector, the government, there's also a lot that the private sector can do. And they play an important role in financing a lot of the reductions in greenhouse gas emissions. And I think particularly the insurance sector can do quite a lot in this area to provide incentives to change behaviour. I'm happy to leave these slides with you, Carl, if you wanted to distribute them to anyone who was interested, because in the slides, on the second last slide, you'll have this list of further reading. These are reports that are not too technical, they're pretty user-friendly, and they are based upon peer-reviewed information. So I hope you might find that, that useful.
That'd be good, and we can distribute it, yep.
No worries. Okay, thanks everyone.
Thank you.
Happy to take any final questions, if you're not all exhausted.
Do any of the models show a tipping point where it reverses? Like, is it a runaway effect and continues until we turn into Venus? Or is there going to be another ice age that we induce because we put more moisture into the,
The only way we're going to get into another ice age is to wait about 30,000 years for the wobble in the Earth's orbit to kick in again. The rate of warming very much depends on the emissions that we put into the atmosphere. So if we continue on the current rate, which is the high scenario, we're looking at a warming of about 5 degrees over this century, and it keeps going. And the other interesting thing about that is even if we were to stabilise greenhouse gas emissions, the warming still continues because there's this inertia in the climate system, and the sea level rise also continues. So it takes a little while to turn the ship around. So early action to reduce emissions has a really big effect.
You talk about turning the ship around. Some years ago, I can't remember how far back, there was quite a concern about the ozone hole.
Yes.
And CFCs were taken out of the marketplace in fire extinguishers and so on and so on. What happened to the ozone hole in the meantime? Has it recovered, or is it? The
ozone hole is in the process of recovering. It's a really good news story, and it shows the effect that legislation can have on the environment. We're aiming on its current path to restore the ozone hole to where it was in 1980 by the year 2050.
Oh my God,
Mhm.
Takes that long.
And those CFCs that were, from our fridges and detergents and so on that were causing the ozone hole are also a greenhouse gas. So reducing that is having a double effect
But it takes to 2050, you reckon?
to get full recovery. Yep.
And when did the action take place? Can you refresh my memory? 90 maybe?
That was in the late 80s, I believe.
80s, was it?
Yeah. Yep. The Montreal Protocol.
Kevin, are there any plans to clone the likes of yourself to get out in the community and educate everybody?
Yeah, I mean, I take your point about communication. I don't think CSIRO is in the media or in the community often enough. There are a few people like me who get out there, but often...
I'll subscribe to that process.
Okay. Well, we tend to put a lot more effort in going into boardrooms and giving briefings at conferences and so on, and that's one important sector of the community. But so are people like you, and I think we need to get into the community halls and the church halls and so on, in both suburban Melbourne and in rural parts of Australia to get the message out. The Climate Commission, as it was, and the Climate Council now is doing quite a lot of that, and I think that's fantastic. But they tend to be a bit more of a lobby group, so they'd be saying more political things than I'm allowed to say. So I think, CSIRO and the Bureau of Meteorology and a number of the universities have a different position. Now, we're meant to be policy relevant, but not policy prescriptive. We don't comment on policy, but we tell you what the facts are, and we try to give you a sense of what's known well and what's not known so well.
That's all we want, are the facts.
Yep.
What's the significance of permafrost melt and methane?
It's very significant. So in parts of the tundra, in northern parts of the northern hemisphere, you have permafrost, and that's keeping the methane in check. As you melt that permafrost, you release large amounts of methane, which is a greenhouse gas. And it's about 20 times more effective as a greenhouse gas than carbon dioxide. The good news there, though, is that if we can reduce reduce methane emissions, perhaps not from permafrost, but perhaps through livestock, it has an effect in about 10 years. So it's one of the shorter lived greenhouse gases. Carbon dioxide, on the other hand, has a lifetime of about 100 years. So what we released about a century ago is still there now, and what we release today will still be there in 100 years' time. But methane is one, it's a very potent greenhouse gas, but if we reduce it in the atmosphere, it'll disappear within about 10 years.
Question on livestock. If cattle are the problem, with eating cows are the problem, what's the solution?
You'd have to do corks back and front because it's mostly burping. But one of the things that CSIRO and other research agencies is looking at is a methane vaccine, which helps to reduce the output of methane and actually improves the live weight gain. So if you can get that dual benefit, that would help.
Is there also some work on grass types that are going to improve that situation?
Yes, indeed. Yep, that's correct.
I agree with the bloke who said eat more whales.
Okay, we all done? We all finished? We all silent?
Many thanks.
All right, no worries. Thank you.